Visible to you, just to give it a cross check. Yeah, please, over to you, quick. Very good. Very good. Very good. All right, that's enough. I think 5 responded and everybody is able to see me and was able to hear my voice. Okay. So now today, previous class, we were doing arithmetic progression we have done, as well as we have covered with arithmetic mean, insertion of arithmetic mean into a two terms. Now we'll start with geometric progression. Geometric progression. This is also we will do in a quick session, because you have already covered geometric progression with your NCERT. All right. So sequence of the type of A, AR, AR square, AR cube, and so on. This is what we call GP, geometric progression. Why so? Because every term divided by the previous term, their ratio is constant. Their ratio is constant and that is not changing. Am I clear? Any term and the previous term, their ratio is constant and that is not changing. Like for example, if you see 1, 2, 2 square, 2 cube, 2 to the power 4 and so on. This is what? This is a GP. Am I correct? Now, what will be the rth term? Rth term for GP, that is A. So say nth term, if I talk about A r to the power n minus 1. See, if you realize in the second term, it is r to the power 1. Third term r square, fourth term r cube. So in the nth term, A r to the power n minus 1. Am I clear? A r to the power n minus 1. Got it? Now, sum of n terms. Sum of n terms of a GP. See, एक GP we have A plus AR plus AR square and so on, AR to the power n minus 2 plus AR to the power n minus 1. This is what sum of n terms of a GP. Now let's do one thing. Let's multiply this series once again with a common ratio, that is SR, and write the series again. Just a moment. Multiply this series by R and write the series again by pushing one term. So this A multiplied will become AR square. This will go here, AR to the power n minus 1. This will go here, AR to the power n. Got it? So I multiplied the entire series with common ratio R and wrote this series again by pushing one term. Now you subtract both of them. So minus, 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 minus. This AR square, this and this, they all will cancel. Yes. So sometimes 1 minus R will be A left here and last term AR to the power n left here. So S is what? A 1 minus R to the power n upon 1 minus R. Got it? So this is what we are going to use for sum of R terms. Sum of n terms. Now, if this is an infinite GP, if this is an infinite GP. Now see, infinite GP means number of terms are infinite. So first of all, in case of an infinite GP, sum can only be calculated if common ratio is lying between -1 to 1. In case of an infinite GP, sum can only be calculated if common ratio is between -1 to 1. Now see, if common ratio is between -1 to 1, this fraction to the power infinite will become 0. So sum of two infinite terms will be what? That limit n approaches to infinite, a times 1 minus r to the power n upon 1 minus r. Now, if this r is a fraction, fraction to the power infinite goes 0, your answer will be a upon 1 minus r. This is what the formula for sum of infinite terms. Correct? Am I clear? Vaishnavi,
Yes, sir.
clear है?
Yes, sir.
Very good. Now we'll do 2 or 3 questions first. Write down a question. Find the least value of n. N belongs to natural number for which sum of the series 1 plus 3 square plus 3 cube and so on up to n terms exceeds 9,000. All right. Your options are 8, 9, 10 and 7. Got it? Give it a try. Then we will run NPA. उसमें आप अपना आंसर टिक करना. Yes, mark your answer in the poll. Least value of n for which sum of the series to n terms exceeds 9,000. Very good. Somebody answered Bombay. Well, you are taking too much of time. See, what do you want that sum of this series should exceed 9,000, isn't it? So 1 plus 3 plus 3 square and so on up to n terms. You want it to be more than 9,000. If you find the sum of this series one time, 3 to the power n minus 1 upon 3 minus 1, it should be more than 9,000. Yes or no? So what do you want? That 3 to the power n minus 1 should be more than 18,000. So 3 to the power n should be more than 18,001. Correct? Now I know 3 to the power 6 is 729. 3 to the power 7 is what? 729 into 3. So that would be 2187. Now 3 to the power 8 will be what? 3 to the power 8 will be 6,561. See, up to 8 terms, this sum is not exceeding 18,000. But yes, if you do it 9, 3 to the power 9 will certainly be more than 6 3 is 18. So it should be certainly more than 18,001. So the value of n will be 9. Least value of n. See, now after 9 means if you take 10 terms, 11 terms, this sum will always be greater than 18,000. But yes, 9 is the first term after which sum is exceeding 9,000. Am I correct? Tanuja? Tanuja? Got it? Now, let's do the next question. The question is, sum of an infinite number of terms, yeah, sum of an infinite GP is 15 and sum of their squares is 45. Find the sum of their cubes. Yes. There's an infinite GP, sum of whose terms is 15 and sum of their squares is 45. So you need to find the sum of their cubes. Quickly. Quickly try. This 19 upon 19 upon root 6 और दूसरे में आएगा root 50. जो आपने वो करते एक बार जैसे सर हाँ सर ये नेक्स्ट में भी एंगल वाला है हाँ एक बार लेकिन अभी फर्स्ट टाइम वाले कर लो क्योंकि उसमें लाइन ट्विस्ट होती है यस एनीबॉडी कार्तिका एनीबॉडी स्वराज now see Sum of an infinite GP is 15. So A plus AR plus AR square plus AR cube. I assume this is the series. So A upon 1 minus R is given as 15. First equation is this. Now sum of their squares they are talking about means A square plus A square R square, A square R to the power 4, A square R to the power 6 and so on. A square upon 1 minus R square. This is as 45. Got it? Now using these two equations, you are going to calculate A and R. Am I correct? Using these two equations, you are going to calculate A and R, and then what you have to find? A cube plus A cube R cube, A cube R to the power 6 and so on. That would be A cube upon 1 minus R cube. Now, first of all, how do I solve it? Let's square the first one. A square upon 1 minus R whole square is 15 square. Now, divide both of them. So, 1 minus R whole square upon 1 minus R square is 15 into 15 upon 1 minus R square. So, it will be 45 in the numerator. 45 upon 15 into 15. Got it? 15, 3 is 45, 3, 5 is 15. So it is 1 minus R upon 1 plus R is 1 by 5. So 5 minus 5R is 1 plus R. From there, R you get as 4 by 6, that is 2 by 3. If R is 2 by 3, A will be 10. A will be 15 times 1 by 3, 5. Now you have A, you have R. Find this. A cube is 125 upon 1 minus 8 upon 27. So 125 upon 27 minus 8. 19 upside goes 27. This is going to be your final answer. Correct? A upon 1 minus R. So it will be A cube upon 1 minus R cube. Am I clear? Well, next question. If x equals to A plus A by R square and so on up to infinite terms, y equals to B minus B by R plus B by R square minus B by R cube up to infinite, z equals to C plus C by R square, C by R to the power 4 and so on till infinite, and magnitude of R is given as less than 1. Then xy upon z is equal to, A option is AB upon C, B option is BC upon A, C option is CA upon B, and D option is AB square upon C. Q. Yes, give it a try. Well, whatever the answer you got, mark your answer in this pool. Yes, there you go. Mark your answer in this poll. Quick. Four people marked A, one marked C. Others? Well, A is the correct answer. Now see, X is what? X will be A upon 1 minus. Now common ratio is 1 by R. So it is AR upon R minus 1. Y will be BR upon R plus 1. If you calculate, it will be BR upon R plus 1. And Z will be C upon 1 minus 1 by R square. Got it? So now, if I multiply X and Y, I get AB R square upon R square minus 1. And R square upon R square minus 1 will be Z upon C. So AB Z by C. This implies XY upon Z is AB upon C. Got it? See how simple it was. Shruti? No. A few points about GPs. Just a moment. Now, few points about GPs. If you multiply an GP with a non-zero constant term or you divide by that, the resulting sequence still remains a GP. But if you add some non-zero constant, to a GP or you subtract a non-zero constant from the GP, it does not remains a GP. Got it? Whenever we have to assume three terms in GP, we will assume them like A by R, AR. See, the only purpose behind this is if the terms given to you, like three terms of a GP, if their product is what they are talking about. Because otherwise, if this if you assume AR square, that is also convenient. This won't help unless product of the terms of the GP is given. But if four terms in GP, you will assume them like A by R cube, A by R, AR, AR cube. If 5 terms you have to assume, then A by R square, A by R, AR, AR square. If you realize in all of them, product of these terms is constant. So that is a purpose behind assuming terms like this. Got it? Like a simple question if I write, product of 3 consecutive terms of a GP is 19. Sorry, not 19, is 216. And their sum is 19. Find sum of 20 terms and also find sum of infinite terms.
Unknown caller.
Infinite terms. If possible. Yes, give it a try. Yes, anybody? Tanuja? Vaishnavi? Vaishnavi? Roshan? Now see. Product of 3 consecutive terms of a GP is 216 and their sum is 90. Now, product is what they are talking about. So, first of all, I will assume terms as A by R, AR. Got it? And their product is A by R into A into AR is 216. That means A is 6. So, yes, from there you get A cube is 216. So, you got A as 6. Now with A as 6, sum of these 3 terms means 6 upon R plus 6R is given as 19. So 6R plus 6 by R minus 13 will be 0. Now multiplied by R, so you get 6R square minus 13R plus 6 equals to 0. Now factors of 36 which add up to 13, so that is 9 and 4. So 6R square minus 9R minus 4R plus 6 equals to 0. Take 3R common, so it is 2R minus 3 minus 2 common, 2R minus 3 equal to 0. So 3R minus 2 into 2R minus 3 equals to 0. So value of R goes 2 by 3 or 3 by 2. Correct? Now, if R is 2 by 3, so first term is what? 6 upon R. 6 upon R means 6 divided by 2 by 3 means 9. Second will be A, that was 6. Third will be R, that is 4. Fourth will be something like this. Now, in this case, sum up to infinite terms is what? A. Now see, sum of infinite terms means first term upon 1 minus R. So here A is not the first term. A by R is the first term. So this 9 is your first term. So 9 upon 1 minus 2 by 3. So sum goes 27. Am I correct? Now, if R is 3 by 2, series will be like first term will be A upon R. So say, first term will be A was 6, 6 upon 3 by 2. So 12, 4. Second will be 6. Third will be AR 9 and so on so forth. Now in this case, common ratio is what? Common ratio is 3 by 2. So when common ratio is greater than 1, sum of infinite GP cannot be calculated. Am I correct? When common ratio is greater than 1, sum of infinite GP cannot be calculated. Am I correct? Now see, just have a look. Now, sometimes in GP, we also see this kind of question that, yeah, these kind of question generally comes in boards only, like school exams only. 0.423 bar. And write X in P by Q form. P by Q form using GP. Correct? So what is X? X will be 0.4, 0.023, 0.00023, take 2, 3, 4, 5, 2, 3, and so on till infinite. This is what your X is going to be. So it is 4 by 10 plus 23 upon 10 cube, 23 upon 10 to the power 5, 23 upon 10 to the power 7, and so on. See, keep 4 by 10 separate and apply sum of infinite terms here. So A upon 1 minus R. Now R is 1 by 100. Got it? So it is 4 by 10 plus it will be 23 upon 990. Now if you take LCM, LCM will be 990. So it is 99 into 4. 99 into 4 is 436. Sorry, 396 and plus 23. So 419. So that is your X in the form of P by Q, and that is another way of writing these terms using GP. Got it? Now one question you will do from your previous year's JEE means. Yes, the question is if 9, 99, 999 and so on up to 49th term. This is 10 times 10 to the power lambda minus 1 upon mu minus 49, where lambda and mu belongs to natural number. Find lambda plus mu. Options are 58, 69, 29, 54. Yes, try it. Then we will launch the poll and see. So whatever you get, mark your answer in this poll section quickly. Yes, nobody? $58. I got one answer from JNV Chahat. Anybody else? Roshan
Yes, sir.
did not get the answer.
No, sir. Doing.
You must have done this kind of questions already.
No.
Vaishnavi, who is there from JNV Chachar, whatever it is? Who is there? Can you switch on your mic, JNV? Dhruvi got A. Okay. See, question is 9 plus 99 plus 999 up to 49th term. See, we can write it like 10 minus 1, 10 square minus 1, 10 cube minus 1, 10 to the power 49 minus 1. You know, it is up to 49 terms. So it will be 10 to the power 49 minus 1. So now you have two series, that is 10 plus 10 squared plus 10 cube and so on up to 10 to the power 49 minus 11111. How many times? 49 times. So if you apply the sum of GP, 10 times 10 to the power 49 minus 1 divided by 10 minus 1, 9 minus 49. Now if you see and compare, your lambda is what? 49 and your mu is 9. So lambda plus mu you get as 58. Got it? Now, write down one more question. S equals to 0.3, 0.33, 0.333 and so on up to n terms. Yes, do it. Yes, anybody? Now see, this is equal to 3 by 10, 33 by 10 square, 3 by, sorry, triple 3 by 10 cube, 3 by 10 to the power 4, and so on. Up to nth term. Now multiply this by 3 and divide also by 3. So it will be 9 by 10, 99 upon 10 square, 999 upon 10 cube, and so on up to nth term. I write it 1 minus 1 by 10, 1 minus 1 by 100, and term. Now this 1 goes in, and now there is a GP 1 by 10, 1 by 10 square, 1 by 10 cube. Got it? Sum will be 1 by 10, 1 minus 1 by 10 whole square, 1 minus 1 by 10. Got it? So answer will be 1 by 3 times n minus 1 by 9 into 1 minus 10 to the power. Am I clear? Now insertion of geometric means. Insertion of geometric means. Now see, we will do it with a question. Let you want to insert n geometric means between A and B. Tanuja? Tanuja? Vaishnavi? Vaishnavi?
Yes, sir.
Did you get everything? Vaishnavi? Now see, between A and B, you want to insert n geometric means. That is G1, G2, G3, and so on, Gn. So that this becomes entirely a GP. So this is what? GP of n plus 2 terms. Am I correct? So now let us assume the common ratio is R. So B is what? B is n plus 1 term. Sorry, n plus 2 term. So A common ratio to the power n plus 1. From there you get value of B as B by A to the power 1 upon n plus 1. B by 2A to the power 1 upon n plus 1. Now G1 will be what? G1 will be AR. G2 will be AR square. G3 will be AR cube and so on. One more thing we need to notice, if I multiply all these geometric means, that is A R to the power 1 upon n plus 1. A R to the power n. Just a minute. G1 will be AR into multiply we are doing. G2 is AR square and AR cube and so on. AR to the power n minus. Last will be nth, n plus 2th, n plus 1th, so AR to the power n. Now this will be what? Take A common, A to the power n will be here. R to the power 1 plus 2 plus 3 से लेके n तक. This is what you got. And we just calculated that R is B upon A to the power n plus 1. So it is A to the power n, R to the power n plus 1. If I write, it's power n by 2. So that will be root AB to the power n. So the most important thing here is that if we multiply all the geometric means, all n geometric means inserted between two numbers A and B, if we multiply all the geometric means inserted between two numbers A and B, then product of all these geometric means is n times is a power n of single geometric mean between them. Because between A and B, if there is geometric mean G, then G upon A is B upon G. So G square is A. So product of all the geometric means inserted between A and B is equal to the nth power of single geometric mean between them. Got it? Dhruvi? Dhruvi, switch on your mic. Spandana? Spandana? Anyways, that would be all from my side for today in geometric progression. Next class may we'll do some miscellaneous series and also get to know about the arithmetic geometric progression. All right. Next class is going to be completely new, having a lot of information for you. Now, just mark your feedback in the here. Everyone, please.